Hello everybody, welcome to this webinar from Nordic Semiconductor. Today we're going to give you an introduction to the Nordic Thingy 91, which is our latest prototyping platform. This one is for cellular IoT applications. My name is John Leonard, I'm a Senior Product Marketing Manager at Nordic Semiconductor.
My name is Bjorn Quale, I'm an Applications Engineer at Nordic Semiconductor.
Okay, a couple of things about the webinar before we begin. Duration will be approximately 45 minutes. You can ask questions if you look in the top right-hand corner of the interface. You can type in questions. We'll take them all down. We can't answer them verbally because of the number of people on the webinar, but we'll take the questions at the end and we'll answer as many as we can. So we'll look at a bunch of things today. We'll take an overview of the Nordic Thingy 91, what's on there. We'll look at the sensors, the features. Obviously, it is primarily to highlight our nRF9160 system in package for cellular IoT with LTE-M and NB-IoT with assisted GPS. There are a couple of other things we'll look at. We'll look at prototyping and proof of concepts in general. We'll look at the sensors are on there, a little bit on cellular IoT compared to other technologies in the LP1 field, and we'll look at the SDK, the nRF SDK. Bjorn will take you through that and an asset tracker example, and we'll do a demo of that, a short demo at the end, and then we'll take your questions, and then we'll be done. So what is it exactly, the Thingy 91? Well, it's an out-of-the-box rapid prototyping kit for cellular IoT. Cellular IoT is quite a complex technology, so we know people want to try this technology out, see if things work early on, see what the potential is, and that's exactly what the Nordic Thingy 91 is about. It supports LTE-M and NB-IoT standards for cellular IoT with LTE, and it has GPS for positioning. It ships with a SIM card from MyBasis, which is a roaming SIM. You can use it just about anywhere in the world, and it's preloaded with 10 megabytes of data plan. It supports Bluetooth Low Energy, the Thingy 91. Lots of sensors that we'll look at, sort of things it can do, and it actually comes preloaded with a sophisticated application, an asset tracking application, right out of the box. And there are associated development tools and an SDK that support the Thingy 91 also. It's a very rugged, flexible little piece of kit. It's made from tough plastic. It's housed in a splash-proof rubber sleeve. You can see there's a couple of interfaces there on the side for connecting to USB, and also a connector for connecting up to a DK if you want to do program and debug, etc. It's only 6 by 6 centimeters, so it's very, very compact, and there's even some mounting holes on the back. So I think Thingy 91 is as comfortable mounted outside as it is inside. So it's really, really suitable for all sorts of different scenarios. And why did we make it? Well, IoT projects are big by nature, and they straddle really the entire value chain, all the way from sensors through embedded connectivity, cloud, analytics, and then at the end, insights. These are all complex areas in their own right. Only the largest companies have lots of expertise in all those areas, and many IoT companies are quite young, startups, they have limited resources. So you need to be able to demonstrate the viability of your idea at an early stage. And this is all about prototyping and proof of concepts, or POCs as they're known. You want to take each section of that value chain and show that something works and works well early on, and then you can refine, maybe get more funding, get management's buy-in, whatever that is. This is exactly where something like the Thingy 91 comes into play. It's a big value chain in IoT, as I said, but the area that Nordic is involved with, which is really about embedded and connectivity, that is getting more complex of itself. So that area alone tends to get more complex now. So it's even more reason to have something like a Thingy 91 where we've taken away a vast amount of that complexity. You can turn this thing on and it starts doing interesting, meaningful things right out of the box, and then you can start seeing how that interacts with the other parts of your system in the cloud and your back end, etc. And of course, it's got lots of sensors because you want to be able to do meaningful things, or you want to see what what the temperature of something is or whether it's moved, etc., etc. So trying to fill that role in the world of prototyping and proof of concept. So looking a bit more depth now, actually what's on the Thingy 91. As I say, it supports NB-IoT and LTE-M, Bluetooth and NFC. We've got in the box, we've got the iBasis global roaming SIM. Lots of sensors you can see there graphically, number of things that the Thingy 91 is capable of doing. There's a pretty powerful lithium polymer battery as a part of this kit with a capacity of 1.4 ampere hours. So I think a Thingy 91 can quite happily run for weeks, months and years even, depending on the nature of its communication and how often it's asleep, etc. It supports photo, which is firmware over the air. So this device can upgrade the modem firmware when needed, upgrade the application firmware when needed. So a true sort of wireless solution. If you want to take it beyond the demonstration aspect of what Thingy can do right out of the box, you can just connect up to an external SDK, an external DK, or a programming device, and you can do standard programming and debugging with development tools. What sort of things can you measure? We've got high G impact up to 200 Gs, temperature, movement, vibration, humidity, light level and color. We've got absolute positioning with GPS, relative positioning, altitude. You can press a button, you've got pressure and you've got gas. And in terms of comms and the kind of actions, as I mentioned already, you've got the two standards, Cellular IoT, and with the NRF 52840, which is also on there, you've got the Bluetooth Low Energy standards, and you've got the 802.15.4 standards. So the device itself can support these standards. Actions out, you've got a programmable RGB LED, you've got a buzzer so you can generate alerts and alarms, and there are 4 high current MOSFET outputs. So you can drive stepper motors or devices that have a higher current demand. It might be more powerful lights or something of that nature. I'd like to say a few words for our partners who we've worked with on creating the Thingy 91. We have Bosch Sensor-Tech. We use their BME 680 device, which is a device that has a number of features. Most specifically, it can measure barometric pressure and altitude, measure temperature, relative humidity, and volatile organic compounds. And it has also an environmental unit which can be programmed to measure an amalgamation of these different values for general environmental levels. From analog devices, we've used 2 devices. One is the ADXL 362 low power accelerometer. This is essentially to wake the device up when it moves, or you pick it up, it comes out of sleep mode, or it's been saving current and will start to operate. But it's an accelerometer in its own right, so obviously it can measure movement. And then there's an ADXL 372 high G accelerometer up to 200 G, so essentially for measuring high impact, or if the thing have been dropped severely or crashed into something, which all fits in with the asset tracking example which we've programmed the Thingy 91 with. And then finally, in terms of sensors, we've got from Nordic Semiconductor, we've got the BH1749, which is a light color sensor for sensing color and intensity of ambient light. On the antenna side, we've worked with Fractus antennas, and we've done, so we have antennas for the LTE, we have antennas for the short range, and we have antennas for GPS, and RF ports for actually connecting up to test equipment and testing. But we've actually got an active tuned antenna circuit because the LTE bands they spread across a fairly wide frequency range. So depending on which band you are using with the Thingy 91, the optimum tuning of that circuit will change. And we have an active tuned circuit to incorporate what is necessary to make that run optimally. So quite a nice a nice addition there to make the thingy work as best it possibly can, depending on which band you're operating in. Quick look at both sides of the device from a photographic perspective. You can see it's quite a lot packed in there, most notably the nRF9160 system in package. You can see there's a nano slot for a SIM card, lots going on there, and there's a few ports where you can solder in pins. We haven't put the pins in because of course we want to keep the thingy in a nice compact box, but if you want to put current measurement pins and some interfacing pins on there, then you can do that as well. Not on this photograph here, it also comes with an NFC printed antenna, which can connect into that NFC antenna port also. So let's take a look at the Nordic devices that we've got on the Thingy 91. Of course, the nRF9160 system package for cellular IoT is the main device here, and this is really what we're trying to showcase on Thingy 91. It's our flagship device for cellular IoT. Very, very state-of-the-art device with the sort of best technology that is available in this area. It has a very clear separation architecturally between application work and communication work. So the application processor and associated things, memory and peripherals, are dedicated to your application work, and the modem and what the modem needs to operate is its own dedicated set of peripherals, memory and processor core. So you don't have to worry too much about the modem. We provide all the firmware for that, and it just operates. But from a design perspective, it just makes development easier because you just focus on the application processor and you don't worry about having to have the modem firmware in the same area as the application processor. In terms of that application processor, we've got the latest and greatest from ARM. So it's an ARM Cortex-M33 that runs at 64 megahertz. There's 1 megabyte of flash with 256K of RAM, and it's got ARM's TrustZone security, which I'll talk about on a slide, which takes the security features of this device up to the next level. It also has an integrated power management IC, and the RF front end PAs and LNAs are incorporated in the system in package, and the device itself has an extensive peripheral set and interface set. If you want to look at this video later on and dwell on some of these tables, I just tried to put some information in here. A lot to go through, but you can see the nRF9160 is qualified for a broad selection of bands, so it truly is a globally compatible device. It's got great sensitivity, maximum output power possible, plus 23 dBm, so really good range performance with this device. You can see that LTE-M and NB-IoT differ slightly. It's 375 kilobits per second maximum with LTE-M, and up to 60 kilobits per second maximum with NB-IoT, and they're slightly different in terms of bandwidth, etc. And NB-IoT typically slightly longer range than LTE-M. It covers the two new energy saving modes, which are eDRX and PSM, which I'll cover a little bit more later on, and it has a standard 50 ohm single-ended output to the antenna. About the application processor, it is an ARM Cortex-M33, as I said, running at 64 megahertz. In terms of DSP and FPU, it has the same as the Cortex-M4F, so it has those in there. ARM TrustZone, as I say, and performance-wise, for those who are interested in core mark numbers, it's 234 core marks. So TrustZone that we have in the nRF9160 is, briefly, this comes really from the Cortex A series devices that have typically dominated the world of smartphones and the like. It's been very, very successful, and this is really about having areas or an area where you can safely know no one has access to that without your say-so. So that's essentially your software, your data and hardware peripherals. So this typically is where you would put the things you need to bring the device back up from a critical error or a critical problem. So you wouldn't typically put your application code in here, but you know, secure boot would be in here. Your over the air firmware update operation would be carried out from here, and certain peripherals, real-time clock, etc. So nothing can really talk to the trusted area in TrustZone without it being explicitly given the okay in development time. So it's a much safer architecture than devices that don't have TrustZone. So it's a big leap forward, TrustZone, on embedded devices in general. The other device we have on there is our very popular nRF52840 multi-protocol SoC. On the Nordic Thingy one, Nordic Thingy 91, this device is handling communication support between the nRF9160 and the USB, because this device has USB. So when you want to connect it up to your development tools, this will handle taking that information, the ATX commands, etc., converting them over to USB, and you can do monitoring, debug, and evaluation from your development tools. But it's a standard 52840 device, so you know, it's compatible with the soft devices we have for this device and the SDK. So there is the ability to do short range development on this device as well, if you want to build hybrid applications with cellular IoT and something, say a mesh technology or something. We don't have that available right now, but you know, we have lots of software that will work with 52840, and you can do some development yourself there. Key features, I think I mentioned it's a full Bluetooth 5 device, so it covers all of the Bluetooth 5 features, has 802.15.4 support, Cortex M4F, same memory allocation as the 9160, 1 megabyte of flash and 256K of RAM, NFC, and loads of peripherals on that device. So the overall prototyping platform, when you get your Thingy 91, looks really as in this diagram. You get your Thingy 91, you've got a SIM card, you put it in, you connect up to the network. You do that using a tool from Nordic called NRF Connect for Cloud. Once you've validated your SIM and you're connected to the cloud, you can start monitoring all the different parameter values that the Thingy supports through a very nice dashboard that we have in NRF Connect for Cloud. You can drive firmware updates from NRF Connect for Cloud also. You can really get this device up and running out of the box, see things happening over the cellular network across the globe if you have to, with all the tools that Nordic supply. So you're up and running very quickly, full end-to-end solution. And in terms of certification, it's the Thingy 91 itself is certified to FCC and CE. We've certified a subset of the bands that the NRF 9160 supports. So bear in mind the device that is on the Thingy 91 can support quite a few more bands than the Thingy has been certified for. But as you can see there, we're certified for, I believe, eight different bands. So the Thingy will work just about anywhere in the world because we've chosen those bands that give that sort of coverage. The 9160 that is on there obviously has gone through even more certifications. So it has CE, FCC, but in terms of cellular, it's certified for GCF, PTCR, the necessary certifications for other countries such as Japan, Taiwan, ISED, etc. It's also ARM platform security architecture certified to level 1. And actually, we've just passed network operator certification with Verizon in the US. Network operator certification is an ongoing job of work for lots of network operators around the world, and you can go to our website and there's a certification page there, and you can always find out the current status of all certifications, whether they're standards bodies or they're network operators. I said it comes with an asset tracking application out of the box. Now that doesn't say that the Thingy 91 is only an asset tracker. You can develop it to do just about anything really. But I think asset tracking is a very primary use case for cellular IoT in general. And I think even things that do other things, you want to know where they are. You want to know what kind of condition they're in, no matter what. So it's a very primary use case. And of course, what sort of things do you track in terms of an asset? That can be containers, it can be valuable equipment and plant and machinery, it can be livestock. We already have gone public with customers who have implemented livestock tracking applications with cellular IoT in the 9160. Valuable products, electric bikes, for example, you want to know where that is. People and kids, animals and pets, parcels and valuable goods or delicate goods that you want to know how were they treated in transit, because they could be destroyed, they could be damaged, etc. So I'll take a look at cellular IoT in general as well now, because I think there's probably a broad range of people on this webinar, and not everybody's familiar with what is going on in the world of cellular IoT. There's not enough time to go into massive detail, but some of the considerations with long-range connectivity, and this is known as low-power wide area networks, or LP-WANs. The sort of considerations you have are, do you need mobility and roaming? What sort of range do you need? What's the security level? Kind of throughput in terms of data? Do I have quality of service and reliability, coverage and density? How many devices can I deploy in a given area? Is it a standardized open? Is it an open standard? Is it non-standardized? Is it proprietary? Do I have carrier network support in my area? And then what sort of ICs are available for the kind of technology I'm going to choose? So whether you go for a standard or a non-standard, is there a broad range of SoCs and ICs with the support I need? Are those SoCs and ICs advanced technology ICs in advanced processes with advanced levels of integration? What kind of security features do they have? And is it feasible to do single device application solutions? Or do I need to have 4, 5, 6 devices to do what I want to do? Can I make a device that will work all over the globe to simplify my development, simplify my logistics and warehousing, etc.? So if we look at the LP-WAN technology landscape, a little bit of background, machine to machine, or M2M as they call it, has been around for a number of years, and that's 2G technology. The time has been ready for a new technology for some time there, because 2G is not very spectrally efficient. There is a limitation to how many of those devices you can deploy in a given area. Quite current hungry, so not particularly efficient, and not very, very cheap either. So not really a suitable technology for this massive IoT deployment we're looking for. And also a lot of networks operators are sunsetting their 2G networks because they are not particularly spectrally efficient. So they would like to have something that uses that bandwidth more efficiently, and that's where NB-IoT and LTE-M come in. You can see where they sit on the graph there. So they're up in the mix with other technologies such as Sigfox and LoRa, etc. However, I think they do outperform those technologies in a number of areas and on a number of criteria. Of course, LTE-M and NB-IoT are 3GPP standards. They've got the kind of quality of service and security that is associated with cellular. Remember, we do banking over our mobile phones, so that's the kind of security that is available on a cellular network. It's best in class. And of course, you've got the ability to have mobility and roaming with LTE-M and very long range with NB-IoT. There's a lot of talk about 5G these days, so LTE-M and NB-IoT, I can tell you they're part of the standard for 4G, but the 3GPP have been very clear that they are in the roadmap into 5G. and LTE-M and NB-IoT will continue to evolve as 5G comes in. So there's a clear pathway forward. These technologies will not be going anywhere, and they will slowly or quickly replace the GSM networks, the 2G networks that have typically been used for M2M. So these are standards, these are license-based, there's quality of service guarantees, there are network operators who own this spectrum, so they know who operates on those frequencies, and they can control who operates on those frequencies, and clearly you can see where quality of service is improved there when you have ownership of who talks and when. The proprietary and unlicensed technologies such as LoRa and Sigfox, they don't have the benefit of that. They don't own the spectrum. They're in unlicensed bands, and they are proprietary. So there aren't so many chipsets and options with those technologies. And Weightless is a little bit in the middle because it is an open standard, but it's unlicensed, so it doesn't work in a licensed spectrum. And of course, the cellular operators, they've invested a huge amount of money in their infrastructure, so they have base stations everywhere. I think over 90% of the world's population is now serviced by 4G. So the infrastructure is there, ready to go with cellular IoT. If we look at the deployment map, you can find this on the GSMA website. Obviously, it's constantly evolving. You can see the different colors there indicate which technologies have had national rollout. Some countries have rolled out both LTE-M and NB-IoT. There's a list associated on this page where you can see each country individually. And this actually just shows national rollout, so that's across the country. There are other pockets in other countries that are grey here, where their larger cities will have coverage, but maybe not all over the country. So I would check that out to check in your region what technology support is available. So I mentioned earlier on there are two new features for LTE for the cellular IoT, LTE-M and NB-IoT. I'll just talk about this very briefly, but because I think it's important. The LTE we associate with streaming of video and various other things with our phones. Clearly, as engineers, we understand that that's not particularly power efficient thing to do. So what's different with this version of LTE? And a big part of that is these two technologies, extended discontinuous receive, which is what EDRX stands for, and power saving mode, which is what PSM stands for. And they're sort of two sides of the same coin. EDRX is about being able to choose how many connections up to the base station, periodic check-ins with the base station you can choose to ignore because you want to save current. And you think, well, I don't want to use the previous upper limit of 2.56 seconds because I'm measuring the outdoor temperature and it clearly will not change in 2.56 seconds. But I'll quite happily measure it every 10 minutes. Well, you can do that with EDRX and go to sleep in the meantime, and of course save a huge amount of power. And PSM, I think, is more longer term than that. That's basically, I want to completely shut the device down, and that might be weeks or months or longer, because you may have a particular use case where I only need to measure once a month, maybe even every 3 months. So you can really use these two features to really get your power efficiency and energy consumption really, really low, and only communicate when you have to. And then finally, that's all I'll say about the cellular IoT standards. I think it's worth mentioning, because we have both the NRF 9160 and the NRF 52840 short-range device on there. There's a really interesting future for hybrid of these two technologies, whereby you can have, say, a Bluetooth mesh or a Thread mesh or a Zigbee mesh, and you can be using cellular as your backhaul communication up to the cloud and beyond. We don't support this in software on the Thingy as you will receive it, But of course, you will know we have SDKs for all of these mesh technologies, and there'll be more and more work and more available in NRF Connect SDK, which the Thingy 91 uses. And of course, you can do your own experimentation with this. But I think it's important to mention, because in the future, I think this could be an extremely interesting scenario where in a particular area, whether it's a house or a building or a factory, you don't need to put cellular into every single node, but you may want to have short-range mesh. And in a number of those nodes, you would like to have cellular, so you have an ability to connect back up to the network. So some very interesting possibilities there.
Okay, so first we'll talk a bit about the development and also the firmware that is on the Thingy 91. The Thingy 91 software is a part of the NRF Connect SDK, or NCS. It does use the Zephyr real-time operating system. Also, one thing to note is the Thingy 91 software is very similar to the asset tracker application that we have for the NRF 91 development kit. The only main differences are that the sensor drivers have been ported to Zephyr and a few other minor changes have been done. Everything is available on the Nordic Semiconductor Playground GitHub account, and the IDE to use is Sega Embedded Studio. That's the IDE we support for NRF Connect SDK. And to be able to program this, you can use an NRF 9160 DK in addition to a 10-pin SWD cable to program and also to debug. And the great tool to use is the Link Monitor application, which is a part of our NRF Connect for desktop application. If we look at the figure here, you can see on top you have the application itself, and then a few different layers: the NRF Cloud, Cloud API, MQTT, which is used to communicate to the cloud. CoAP is another way. We have an example for that too, a different one. Then we have the BSD lib, which I'll talk a bit more about later. That's essentially how we communicate between the application MCU and the modem itself. And yeah, you have the link controller, AT host for sending AT commands to the modem, and some other things, Zephyr kernel, board support, etc. Some different drivers. So there's a lot of different things as a part of the Zephyr RTOS and NRF Connect SDK. So just quick overview of why we chose the Zephyr RTOS. There are numerous other RTOSs available. One of the main reasons is that Zephyr was designed and built for low power wireless, and Nordic Semiconductor has a big focus on low power wireless, first in Bluetooth and now also in LTE. Zephyr is also independent. It's part of the Linux Foundation project, and contributions have been made by over 300 industry embedded experts. And everyone's able to contribute. So you can easily contribute via Git, for example. Zephyr is also very scalable. Very small memory configurations if you have a memory constrained device, but also very powerful and feature rich. So if you have a big device with a lot of memory and a lot of processing power, you can of course use those applications too. And all of the main popular IP standards are supported. So whether that be MQTT, CoAP, etc. We have support for everything, and we also have different examples that show how these are supported. And the great thing about that is that means that we can focus, Nordic Semiconductor can focus on other important features. So we can focus on a DFU solution, some kind of firmware over the air upgrade, for example, and other cool features that maybe not as easy to get right. So over to software architecture. As we can see on the graph here, you do have on the application processor side, which is using a Cortex M33, we have the user application. and then the application layer IP stack. So whether that be CoAP, MQTT, HTTP, lightweight machine to machine. Then we also have the secure BSD socket to communicate between the application processor and the modem. And on the modem side, you have the different communication standards, IPv4, IPv6, TCP, UDP, TLS, or DTLS. And then you can see the LTE stacks. So this is kind of similar to our Bluetooth side with a soft device to a certain extent, if you're familiar with that. It is a complete, easy-to-use solution. We do have all the different connectivity and application software that is needed. Especially the link monitor tool is very good for debugging connections. Support for over-the-air modem and application updates. And also reference design, so that would be the Thingy 91 with multiple sensors where everything works out of the box. And we'll show that in the demo later. We also do have support for thin modem operations if that is required. So that basically means just using the NRF91 as a modem, so just as a connectivity chip in essence, and using another application MCU if that is required. So I'll just go quickly through the demo itself, the Thingy 91 asset tracker demo. So basically what it does is it sends not simulated GPS coordinates, it sends real GPS coordinates now. It used to send simulated GPS coordinates, but now we are using the GPS. And what we need to do there is we need to use a power saving mode when we are using LTE. So basically when LTE is on, the GPS is off, and then we put the LTE connection into a power saving mode, a low power mode, and that's when we can run the GPS. We're also showing real accelerometer, temperature, humidity, air pressure, and air pressure data to NRF Connect for Cloud. And I'll show afterwards how the demo is running and what different data you can show on the cloud side. And the source code is available for connecting to the Thingy 91, like I mentioned earlier. In the figure here, we can see the Thingy 91 is essentially the MQTT client. And then it communicates via the LTE connection, then to the LTE base station, then to the internet, and then via TCP/IP to NRF cloud, all using essentially the MQTT example or based upon that standard. So to get started, it's quite simple. So if we look to the charts on the right, you go to NRF Cloud, you create a user there, and then on the top left corner, you press the plus button, you click on LTE devices, you activate your iBasis SIM card, which has been given, and it's quite easy to do. Verify the SIM card, and then it should work out of the box. Then you insert the SIM card, power up the Thingy 91. You also need to, when running this demo, you actually need to hold in the button in the middle of the device for a bit to turn on the GPS. And then you associate the Nordic Thingy 91 to your user account using the IMEI code and the PIN provided. And that you can see on the PCB itself. So you'll need to remove the orange cover. Yeah, and then afterwards we'll do the demo, and you'll see it may take a while to acquire a GPS signal, so give it a few minutes, and also make sure to place the device somewhere outside, preferably. Yeah, and in addition to that, we do have MQTT API, webhooks, if you're familiar with that, if this and that, and there's also a lot of different options there.
Okay, thanks Bjorn. Nordic Thingy 91. So we've taken you a run through the hardware and software there. You can see it's available from all our online distributors. Some of our major online distributors are seen here. You can find out more on the Nordic website. Okay, so here we are. We're ready to do our demo with the Thingy here, Thingy 91, and Bjorn will take us through. Thanks, Bjorn. Away you go.
Okay, great. So here we can see I'm connected to my NRF Cloud account. We can see that 3 LTE devices are currently connected to this account. To add a new device, you just press the plus button up here, and then click on LTE device, give in your iBasis registration. I explained this on the webinar. It's very simple. SIM cards, here we can actually see which SIM cards have been registered to this account. You can also see how much data has been used, and you can also buy more data if you wish to do so. We also have a device API for the NRF Connect for Cloud. And here's some great documentation if you want to use the NRF Connect for Cloud. And last but not least, we have the devices. And here we can see there are currently 3 devices connected. This one on top is the Thingy 91. That's the one that's green. And the other 2 are NRF 91 dev kits. So if I click on the Thingy 91, we can actually see that we have gotten some GPS data. If I zoom in here, you can see this is our office right here. So that's good accuracy. Air pressure is quite stable, around 101.9. Asset orientation, I can actually move this in real time, and we can see it is being updated. That is the time as of right now, and we can see the orientation of the device. That's great if you have some sort of parcel, for example, some kind of asset, and you want to see the orientation of the device in real time. We can see the different messages that have been sent here. So if I go up, you can see some different data was sent first, and then I turned on the GPS by holding down button 1 for around 5 seconds. Then the GPS ran for around 360 seconds maximum to get a GPS fix. And then after that, the GPS is turned off and the LTE link is turned back on to send the different data, but also to send the GPS data. And once that is done, you try to reconnect. Yeah, you reconnect to the GPS. You put the LTE into a power saving mode, and yeah, and then you repeat that process. If we go here, you can see the temperature. It fluctuated slightly here, went down to 23.5 degrees Celsius. That's because we had the window open at one point. Humidity also fluctuated due to the open window. And last but not least, the reference signal receive power has remained quite constant. We are very close to a base station, and we're right by a window. Here we can see the LTE Link Monitor tool. It's part of the NRF Connect for Desktop. And we can see we're trying to get a GPS fix here. And down here, we can see different AT commands that you are able to save. So the XC band, for example, what that one will do is it will lock the LTE to a specific band if you wish to do so. System mode, that can be to change between LTE-M1, narrowband, or GPS modes. You also have the modem trace AT command if you want to take a modem trace. Last but not least, over here, we have a bit of different data here. You can see if the modem's on, the LTE link is good or not, signal strength, etc., which network you're connected to. And down here, we also have a location API. So that's actually a great tool if you want to find a course position of which base station you're connected to and where that base station is located.
Great stuff, Bjorn. Thank you so much.